Hi, in our first class, we're going to go through the most simple elements, the uniform rod. So it is a rod with a constant cross-section area, and it has a elastic modulus. It has a original length and a force is being applied to it. So how long that rod is going to stretch or compress, it all depends on these four factors: the force, the area, the certain type of materials, and also the original length. For the Young's modulus, stress over strain is the elasticity. Okay, and the stress is also the pressure or the force over area, and the strain is the amount is stretched over its original length. Okay, simple geometry, we factor out F delta length is A times E over L. Since it's a uniform rod, okay, so area never change. And E is also constant along the rod, and the original length is not changed. So we can call that K, because all three numbers are constant. So we're gonna simulate the rod with an element. We always need a reference frame for all simulations. We call this spring K, okay, and it has a spring constant K. The first note we call it I, and the second note we call it J. Any force applied to J, we call it Fj, and any force applied to I is called Fi. All the movement along I is called Ui, and any movement on J is called Uj. So far, nothing fancy. We just simulate the rod with a spring element. Now, we're gonna apply these equations to the elements here. So Fi equal to K times delta L, which is Ui minus Uj. Same theory when I'm standing on node J, okay, what I see is the force J, and from that point, Uj minus Ui. So in the node I is Ui minus Uj, and in the node J is Uj minus Ui. We take away the brackets. Just multiply the terms within brackets by k. Nothing fancy. I just rearrange that thing and times by k. And then I factor out the k. I have two equations, and I turn that into a 2 by 2 matrix problem. By the way, if you want to survive in this course, you must know how to do all the matrix operation very well, because you use it all the time. Okay, now let's give some names to this matrix problem. The first portion of it is called a nodal force vector. This 2 by 2 matrix is called a stiffness matrix. And finally, that vector U is called a nodal displacement vector. Please stay tuned. I'm going to show you an example very soon.